Okay, Descartes came up with a way to help us a little bit as far as our expectations. He has his rule of signs here, and we can say that the number of possible positive real zeros is equal to the number of times I have a sign change as I go along my polynomial here. Every sign change I count, and that's a possible number of positive real zeros. Now, focus on the real here. If some of them, if some of the zeros are not real, then you know that they're going to, like if I have 2i, like I had on the last problem, it's going to get a buddy to come with it. 2i is going to go with negative 2i. They're both going to be there. So then it's going to be, if it doesn't work out for the possibilities, it's going to go down by even numbers. So if I thought I had 4 and then I don't, it could go down to 2 or it could be 0. But the point is it's not going to go down by ones, because if you have imaginary roots, then there's always 2 of them. Remember last time we talked about the fact that if you every imaginary and every irrational root has its buddy that comes along with it. So they're going to go down by 2s. The other thing to think about here is if I plug in a negative for the function, I always plug in a -1 to see what happens. Then I look at the sign changes again, and that tells me the total of negative real zeros. They're possible. And they also go down for the same reason by an even number. Okay, so that's hard to understand without actually seeing what's going on. So here we go. Here's our example. We have a polynomial of degree 6 up here. And we're going to look for the sign changes. So remember, starts out as a positive, okay? So it doesn't say that, but anyway, it's a positive. And it changes to a negative, so that's 1 change. And then it changes back to a positive, so that's 2 changes. And then it changes to a negative, and then it stays negative, so no more changes. So that means 3, or if you go down by 2s, 1 possible real zeros, or none, okay? But the point is 3 or 1. And then we also do the same thing with, notice what we do here. Let me just talk you through it up above. If I plug in a -1 into x to the 6th, that's not going to change anything. I'm still going to have a 1. If I plug in a -1 to an odd degree, an odd exponent, it's going to translate that to the number, and I'm going to get a +2, right? If I plug it in here, no change, so it's going to stay +3. If I plug in a negative here, it's going to change to a +10. If I plug in a -1 here, it's not going to change anything, so I get a -6. If I plug in a negative here, it will definitely change that 8 to positive, and I can't change a constant, so negative. Okay, so how many changes happened here? Well, I went from positive to negative, I went from negative to positive, and I went back to negative. So that's 3 negatives, okay? And we already said there were 3 positives. So three positives and 3 negatives. And it could be 3 or it could be 1 or 1. Either way, okay. So you could plug in something other than -1, but I'd plug in -1 because, or -1, because it just makes it easier. All right. So if it is 1, then we have to say there's 2 imaginary. And if there's 1, yeah. Okay, so anyway, you get the idea. So determine the possible number of positive real zeros, negative real zeros, and imaginary zeros for the function. Okay, so remember, this is possible. All right, so what do we have here? We have from positive to negative, from negative to positive, from positive to negative, back to positive. So that's 1, 2 changes, 3 changes, 4 changes. Well, it looks to me like I have a possibility of 4 positive, or 2 positive, you know, or 2, or maybe I don't get any. It's possible I get no real roots, maybe, that are positive, and rational. Could be irrational. Doesn't have to be rational, you remember. So let's see here. Let's plug in a -1. I'll do that in green up above here. If I plug in a -1, I still have a positive 2. If I plug in a -1, I get a positive 8. If I plug in a negative here, it won't change a thing. If I plug in a negative here, it changes it to a positive, and I can't change the positive 1. So you see there are 0 changes, okay? So there are 0 negative roots. Okay, I know that much. There's 0 negative roots. I might have 4 positive and 0 imaginary. Okay, or I might have 2 positive and then it'd be 2 imaginary. Okay, I guess I'll circle them like that. And then I guess I might have. Would they all be imaginary? No, they wouldn't all be imaginary. That thing's going to have to cross somewhere, right? No, it doesn't have to cross anywhere. No, they could all be imaginary. Doesn't have to cross. They could have all 4 imaginary roots, okay? What if you had a function like this? I don't say this is what this is doing, but what if your x to the 4th did something like this, and then it went back up? Okay, we know it's an even function, so it's not really going anywhere. And we know it's a positive 2, so it started on high and it's going back to on high. It started high up here and it ends up high up here. And it may never touch. It may be all up here. And it never ever hits the x-axis, so I don't get any real roots. So they're all imaginary. Is that a possibility? Sure, it's a possibility. Okay. So all that to say, these are my possibilities. I think I'd be content if you said this. I know there's no negative. You shouldn't tell me there'd be no negative. I can piece the imaginary part together for myself.